Hi, Sarah. Yeah, I just started the recording of the meeting, so yeah,
Hi, everyone.
notice. Okay, and yeah, since the recording is started, I would say the meeting can officially begin. Maybe one or two people are joining later, but yeah, that's how it is. And yeah, welcome everybody to the first interim meeting of the Energy Fault Detector Challenge. And yeah, this interim meeting is yeah mainly thought to be a stage for you participants here, so that you can ask any questions to us in personal if you want, and that you can also discuss solutions. And yeah, I also can go over certain things regarding the challenge again from which may have been not clear from the kickoff. But yeah, so the first point would be: are there any active questions? Is there anything unclear which we should answer, or is there anything you want to show us?
Don't all speak at once. I actually wanted to ask something, if you don't mind. There's two groups. So I think Tullio and Safai, uh, I'm talking to you two basically, and Arshia. You signed up on the registration form. So Arshia and Safai, you've signed up separately, and Tullio signed separately from Gianmarco, but you both from the same organization. Did you are you doing it? Are you working separately or together?
No, we are working separately because we have two different models, but
Okay, okay.
maybe we'll see later if it's not a problem.
It's
If you
fine
want
for you
to
to
join
work
together.
separately. It's fine for you to work separately. Because I noticed that you were from the same organization. I thought
Yeah,
maybe you'd
yes,
just
we are in the same group,
yeah.
research
Oh
group.
yeah, okay.
Yeah, okay.
Yeah, no, work against each other. That would be good. See who's
No,
better.
no. Yeah. No, because we are developing two different models, but
Oh, yeah,
uh,
okay.
but we'll see. Maybe we are going to work together. I don't know at the moment.
But Arshia has written that they are working together. And you mentioned it in the list. Aha, team. Okay, so you've written in under the column team members or supervisors. You've put the number. I guess that okay. Is that what you meant? Because you've written next to so person 5 has written 6 next to their name, and person 6 has written 5 because you mean you're working together. Okay, I think you should be if you're submitting one solution, I think you should be one participant ID. So put one person's name next to 5 and put the other people next under team members. So I don't know who you want to be the main person, but put the second person in column G, and then just delete line 6, and then there's no participant ID 6, and then the next person can be ID 7. Did you understand that? Did it make sense? All right.
Sorry,
Okay.
but maybe I understood it wrong. You said you work on two different models and you want to submit both of them.
No, we're talking about two different groups of people. So Tullio so there's Tullio and Gianmarco who are working separately, and they're going to be separate groups. But then there's Arshia and Safai, who are different people in a different group, who are working together, and they've filled out two participant IDs. So Tullio and Gianmarco don't need to change anything. They keep separate, but Arshia and Safai turn that into one group, one ID number.
So yeah.
Does that make sense now?
But in Kaggle, you have 2 submissions of them. Asia and Safai, you submitted separately, correct? In Kaggle?
If you submitted separately in Kaggle, then you should be separate. I guess.
Okay.
So if you're submitting in Kaggle separately, why are you saying that you're doing it together? Don't you want to have separate? If you want to have separate submissions, then maybe you should just say separate. Or you're trying to say you want to do separate submissions, but you're actually doing it together. I don't really know anymore what you just. If you want to do it separately, then keep separate. If you want to do it together, then put your ID together. But then you shouldn't have separate submissions. See, people are writing, so waiting for the text to come through. You could also speak. Might be easier.
Yeah, but maybe you don't have to use the same Kaggle account for both. So you could just say one of you is submitting, and whoever is the one who uploads the submissions can just upload those CSV files. And if you have them on separate PCs, you can just at first send the CSV file to the one who submits it. So
okay, I think you can do it how you want. If you want separate results, then keep it separate. If you want separate ratings, keep it separate. If you want to be the same, put them together, and then we'll look at them together. I think it's
One thing you can also create a team in Kaggle. Then if you submit as your team, then the best score of your team is in the leaderboard, not each of you.
Yeah. Sounds like a good plan.
okay, yeah, sounds indeed like a good plan. And currently, then we do have effectively 2 submissions on the leaderboard right now, and not 3, when I understood it correctly. Okay, then maybe the question again, because some people joined again after the discussion started. Does anyone have a specific question for the challenge, or does anyone want to share anything? Otherwise, I can also start the round with maybe explaining a little bit, how the baseline of the energy fault detector was configured, and how effectively how we could enter a submission. So just in case it is not clear for everybody how to submit, or where the models could be improved or something, would just be as a substitute for actual questions. Maybe they come along with it.
Who
Okay.
submitted? Who submitted so far? Afad and Archie and Sapphire. Any of these people here? So Sapphire and Archie here. Do you want to tell us something about what your method does, or you're not ready to do that yet? Or you're not even able to speak? Archie and Sapphire.
This is my
Yeah,
first
we're not
time
able
here,
to.
so I'm just taking a look to the whole exercise, the Kaggle page, because last week I wasn't in the meeting. But I'm very curious about the data set.
Mhm.
They are at the office. They are not able to speak. Okay.
You don't want to disturb everyone else in the office. It's very kind of you.
Not so funny. Not so funny.
Yeah, okay. So you are curious about the data set. What exactly? So just how it is structured in general, or are there specific aspects of it?
Jorge, I think that was a question for you.
Sorry. Yes. I mean, sorry. I was reading the evaluation part in the on the Kaggle page. Okay. About this care, this combination. I mean, just reading like this. How does this evaluation metrics correspond to the leaderboard, to the score?
Mm-hmm. Yeah.
Okay. Yeah.
The CAS score that is calculated on the data set consists of 4 subscores, which are separately calculated, and then in the end there's a weighted sum over the 4 subscores, which result into the final CAS score. And this one is evaluated on roughly half of the data for the public leaderboard, and then we have half of the data set as scoring for the private leaderboard, which will be released at the end of the challenge, which determines the winner. And there are also 5 events randomly chosen, which are ignored, so that it is just harder to reconstruct which of the data is used for the private leaderboard. Since the data is publicly available, we want to at least do some measures against just submitting the 100% solution or something.
I'm familiar with this method. Okay. So it's a weighted sum. This score that I see of this care metrics, CARE.
Yes.
Okay.
So maybe I share the kickoff presentation. So we have those 4 aspects of the CARE score: the coverage, which is basically the F beta score on data sets where there are anomaly events. So we had defined some timeframes where we expect anomalous data. So then the F beta score is calculated within this time frame on anomaly events. So where there's an actual anomaly. Then we have the accuracy, which captures how well the model does not raise false alarms on normal events. So we have events in the data where nothing unusual happens, and your model should be able to also recognize that no alarm is necessary here.
Yeah,
then we
avoiding
have
type 1 errors. No? Okay.
Hmm?
I mean, to avoid false alarms.
Yeah, exactly.
Type
And
1 errors. Yeah.
then we have the reliability, which just does not look at every timestamp of every event, but takes all 95 events or all 50 events if you are in the public score, and calculates the F beta score based on the classification of the event. So this is an event-based score. Those the other two scores are point-wise. So for every timestamp, and this one is on a macro base. And then we have the earliness score, which evaluates how much before the actual fault happened was an anomaly detected. And those four aspects are then summed up while accuracy is weighted twice, because this is the only measure which reflects how good the model is in identifying normal behavior correctly. So coverage and earliness are both for anomaly detection, and reliability is a macro score. It's a event label based score.
Okay.
But it's all also described in detail in the linked paper where the evaluation method is published. So we take the same weightings as in the paper. I can also go into that into detail if you want, depending on.
No, it's okay. I mean, if somebody have more questions, I can take for sure. I can take a look at this presentation that's available in the.
Yeah, I think the recording of the kickoff is also available in the WIN.
Exactly. That's the answer. Exactly.
Yeah. Okay. Do we have further questions?
Yeah, a lot of things come to mind. I mean, I once participated in a fault detector for elevators. Okay. And this is more like an anecdote. I mean, it was a bit tricky because are you going to treat this as a regression problem or as a classification problem?
Yeah. So basically, since we do not have enough labels for reliable classification, it's basically a regression problem where we just so our approach at least treats it as a regression problem. Of course you can try to set up a direct classifier, but what we do is we use autoencoders to learn the normal behavior. So to do a multidimensional regression of all signals that we have available in the dataset, and depending on how well this regression works, we then decide which points are anomalous and which are normal. So basically, we try to learn normal behavior because we have some defined areas where we really much expect only normal behavior, and those are this is the majority of the data, and we have only a few selective examples of faults, and those faults can be very individual and very different. So it is much more easy to define what is normal and then say from there on what is not normal.
Okay.
Directly classify.
I understand that wind turbines. How many? The thing is that, for instance, for this case of elevators and other problems, I mean, normally these exercises are typically very with these data sets are very imbalanced, no? Because failures are rare, no, the nature of failures, and these are very imbalanced data sets. However, I remember that when I was doing the feature engineering, okay, and this is like a tip for all the group. I don't know, maybe it works here, maybe it doesn't. It does not work here. One key one key feature that I let's say derived or whatever is the failure rate, okay, of the turbines, because normally all the turbines, and this is typically reliability engineering, basically, all the items that has a high failure rate, okay, they are probably they are going to fail. I mean, they're going to be failed more often. I mean, if it's failing right now, it's going to fail more and more. No?
Yes, this kind of analysis unfortunately will not work on this data set because we where can I show it? Okay, maybe on the site itself. Okay, just have to move this out of the way. So basically, what or no, maybe it's the publication itself. Where we have the data set. Okay, where's the table? Just yeah, here maybe. Yeah, here we have an overview of the data set, and we have made sure that we have roughly the same amount of anomaly events as compared to normal events. So we have selected a few time frames of each turbine. So we don't have the entire recorded data of a turbine, but just a few selected time frames, and then a training year before that time frame. So there are some turbines where we have multiple examples, but
okay.
Yeah.
Okay. I mean, yes. I mean, it's part of the same question, no, for the feature engineering stuff. I mean, you're telling me that there is no way that I can calculate the failure rate of each wind turbine.
You can calculate the failure rate, but it is very trivial because I think the turbine that has the most events in this data set has like 3 events. So an event is always this. When I talk about an event, it's always this composition here, where we have 1 year of training data and then a segment of prediction data, which can contain a week of data or maybe a month. And inside this prediction data for an anomaly event, there is some fault happening, one fault that we clearly identify together with the operators. And this fault can be detected earlier than it is occurring in the data. So we have like roughly 40 or 45 of those anomaly events, and we have how many is it? 20 different turbines in the data set, roughly saying. And then the other half of the data set are normal events where we also have 1 year of training data and then prediction data which only contains normal behavior, so where the model should not raise false alarms. And with this, a failure rate analysis would always say, either the turbine has 1 or 2 failures or none, maybe. So
okay.
It's kind of difficult because we also needed to anonymize the data set to a certain extent to being able to publish it. So we cannot. We also anonymize the time in the data set by shifting it by a few years. So they are consistent within the year, but they do not show the year which the data was recorded in. It was we just fixed it to the year 2022.
Okay, and how could you take the aging process into the anomaly prediction as feature? Because I mean, the more operational hours these turbines have, the more are they going to fail. I mean, that's important. How did you cope with that?
In this data set, this information is not available.
Okay.
Yeah, we do not know how old the turbine itself is. But yeah, since, as I said, our approach was to fit a normal behavior model, which then implicitly learns the current state of the turbine.
Yes.
And we then can we can only tell with our method what is the difference from the learned normal behavior to the predicted data. So if this aging effect is not reflected in the training data, then we cannot tell it.
Okay. And you, I mean, all the fleets, these are different. I saw that there are 3 wind farms. These are different manufacturers.
They are different types of wind turbines with also varying amounts of sensor data. So some wind turbines only have like 80 features, and the other ones can have up to 900.
Yeah, different sources, different channels, different scale. Okay. Okay.
There's a question in the chat.
Could you please explain a little bit about the status ID data column in the data set? How reliable are they? That's a good question. As stated, I think in the dataset description and in the paper also, we have a status type ID column in the dataset. In the paper, we also have a description what the status type IDs mean. So along with the sensor information of the dataset, the operator also records a status of the wind turbine. And this status, we anonymized or grouped it into those 5 categories of statuses. So every timestamp that is flagged with the status ID of 0 resembles normal operation without limitations according to the operator. This is the known status for the turbine at the given timestamp, and then status ID 1 means the rated generation, the rated power generation, and so on, as it is displayed here. And yeah, those status IDs are not that reliable. They can be used to roughly filter the data for normal behavior. So data in the training data set, which has status ID 0, is most probably does most probably resemble normal behavior, but we cannot we can only guess this to a certain degree, and we manufactured the data set so that we are very sure that that the status ID 0 in the training data resembles normal behavior, but you cannot rule out that there are some flaws in the recorded status IDs. So one approach of improving results in this data set can also be to get some more indicators about normal behavior. Maybe trying to fit a power curve and trying to derive a normal behavior in this way. I actually know maybe that is so I actually know that the other entry, so Fahd, who also made an entry here. He contacted me a while ago. He was working on his master thesis on the dataset before the challenge even started. And then I suggested that he can also that he can also enter his work here. I know that he really much focused on looking at the status type ID and on looking at indicators, what is normal and what not, and not that much focus on machine learning models itself, for example. But so status type IDs can give a good indication about what the operator assumed the asset to be in which status it was, and for a status ID like asset down due to fault or other reason, this is a very accurate status ID because it's easy to determine whether the turbine is in fault mode or not. But especially for the normal behavior one, this can be refined. It is not fail safe, and also data within this event time frame where anomalies should be detected, they are also labeled with status ID 0, so with normal behavior, because that's the whole point of the data set. The operator thought within this orange data frame that the asset is in normal behavior mode, but in reality it is not, since fault is occurring in some time, and the fault can actually be detected way before this, but the operator status was not able to detect it before. So as I said, to a certain extent you can trust the status ID in the training data set, but it can also be improved definitely.
And then maybe just in the next interim meeting, I don't know, Christian and Florian, if you want to ask people to present like more formally. I was going to say that this is an opportunity to present, and who wants a slot, to try to actually see if people can. It doesn't have to be finished or anything, but just to show their general method, because in previous challenges it's been quite interesting then when people have actually talked about their methods, because then people have got ideas from each other. And so I'd just like to encourage that. I don't know, whether you want to send a message a bit before the next interim and ask if anyone wants to submit a couple of slides, or just book a slot so that we can plan it or something like that, just to encourage people to to present something, however small it is. Because I think it's a good thing to do.
Yeah, we can definitely do that. That would be interesting. I can also ask Bart if he wants to present his method in some way, because he already presented it to me. But I think that's a high probability that he, if he has time, can show that. So I don't know. Then it's just the question if anyone else is willing to do that. So it is just it is not about presenting your whole source code or something. It's just about the general ideas that you are trying to implement. So that we can inspect the problem from different angles, just as Jorge did with the failure rate analysis, for example. That's an idea that's totally different to the way that we approach this problem. Unfortunately, in this case, it might not be well suited, but this is of course valuable information and a good angle to look at the problem. So we can all learn from those approaches. So I don't know, is there anyone maybe here who also wants to join the presentation group for the next interim webinar? You can also think a little bit about it. and decide later. But yeah, would be cool to have like 1, 2, or 3 slides. Maybe doesn't have to be an elaborate presentation.
Yeah, maybe Oshia and Co can find a quiet place to go for the next one so they can actually speak. It'd be cool. I can see you're writing something now. I'm sure you're writing. We'll present next time. Let's see.
Yeah, depends on how good your prediction model is for the text messages.
Yeah. Okay, we might be able to do a short presentation.
Mhm.
I'll take
Would
that to
be
mean a
very
yes.
nice. Okay. Yeah, and as I said, I can also just present our energy fault detector solution for the problem. If this is interesting for you, maybe you can also get an idea of how you can approach your own presentation with that. So it is all already available to all entrants. So we have linked the repository at several points in the We Do Wind forum and also on the Kaggle site. So all those notebooks and the code is available. And yeah, what we basically did, what I also said before in the discussion, that we train normal behavior models, which basically try to learn the normal behavior in the training data, which is why we always have 1 year of training data before each event. And with this learned normal behavior representation, we then analyze the prediction data and see if our regression is failing. So basically, what we did is we did a hyperparameter optimization for each of the 3 wind farms. So we took all datasets for each wind farm and calculated our regression loss. So the mean squared error on those on the validation section of the training data, and we fine-tuned our hyperparameters of the autoencoders in such a way that the regression works as good as possible for the normal data within the validation section of the training data that we chose. And so in this way, we created 3 different configurations for our autoencoder model. And this is basically then used to analyze each event of the data set. So our approach works on just having autoencoders learning normal behavior, hyperparameter optimization set on top of it, and then we have also a pre-processing pipeline which just relies on the status type ID which is given in the data, and also some necessary steps like feature selection. We, for example, drop every min, max, and standard deviation feature. So for many features in the dataset, there are different statistics like average, min, max, and standard deviation, but we only use the averages since the problem is maybe too complex or maybe it is too redundant. The data may be too redundant otherwise. I see a question there. I try to read and answer it on the fly. So what was the loss for the hyperparameter optimization, and did you only use status ID 0 for normal behavior learning? So the loss for the hyperparameter optimization, as I said, we took some data out of the training data set to use as validation data. And on those validation data, we calculate the mean squared error of the reconstruction. So the autoencoder takes the whole input data and outputs data that has the same shape as the input data, so that we can compare the output to the input, which is the reconstruction error. And for this error, we use the mean squared error to quantify it. And this mean squared error is minimized on the validation data of the training data set, and we used as described in the paper, everything that is considered as normal we use for training and validation. So status ID 0 and 2 were used. Yeah. And that is basically it. Or okay. For example, I think here we even only use status type ID 0 for the training of the already hyperparameter optimized model. So did you filter normal data based on the first year time period? Yeah. As it is done in this example here, you can use the status type ID to filter the training data. So we use the entire training data and generate a Boolean array which indicates which data points we want to use for training and which ones should be ignored. And this is then used for to fit the model. And in this example, we have just chosen status type ID 0, but ideally you would also add status type ID 2, for example. Or if you define your own status, you can also add this into there. And we only use the indicated training data in the year for training. Yeah. There are also more fancy approaches which one could do. So what we also did is just use a normal multi-layer autoencoder. So there's no fancy stuff like conditioning on some input features or time series or time correlation stuff or something. So for this example, there's only a multi-layer dense autoencoder with fully connected layers. Yeah. Okay. And that's basically already almost the entire idea. I forgot actually one point, which is for determining which points are anomalous and which are normal, we of course have to define some kind of threshold because we have continuous variable, this reconstruction error, and we have to decide when this reconstruction error is on a normal level and when it is not. So what's actually happening is that we have some threshold selecting models which, based on the training data set, find some ideal threshold to tell apart normal behavior from not normal behavior, and this is also incorporating the status, the normal index that we derive by the status ID. So it's also all available in the repository, but basically we try to fit the threshold so that it can best classify it can classify normal behavior and not normal behavior according to the given status type ID. So the aim of the threshold is to have almost all data points with normal operation mode below the threshold, and all all data points with not normal operation mode above the threshold. That's basically the entire idea. And yeah, as I said, there are a few approaches to expand upon this concept, but there are also a lot of other possible methods that you are probably currently working on. I think either you can use different methods than autoencoders, or even a direct classifiers if this works for you. We found out for ourselves it is very difficult to train direct classifiers, but a lot of possibilities. Are there any questions that arise from this, or maybe that came to mind during the discussion?
What's the time span for the competition?
The time span for the competition is we have 25 days left to go until the competition ends in the end of November. So the 28th of November is the closing date, and then on the 5th of December there's the final event where we present the private leaderboard and where also everyone who has registered should give a small presentation about their approach that they used, so that we can determine the winner and give out the certificate.
Okay, thank you.
Okay. So if there are no further questions, maybe I think it's a very good idea for the next interim meeting to have some presentations, kickstart the discussion part. But aside from the interim meeting, of course, you can also always contact me if you have any questions in between that we can easily answer via text. Or we can even, if there are larger questions, schedule a short meeting and then post the outcomings of that in the discussion thread or something. So, but the best point would, of course, be the next interim meeting, or now if you still have any questions now. Okay. So I think all questions are answered right now, or at least it seems so. So Sarah, do you have to add anything or?
No, just if any questions come up between, just write them on We Do Wind, and the best way to do that, if you do it in the feed, and then you can notify, you can click on notify, and then we'll all see it. And you can also tag, I think, Christian, and then he'll definitely see it if you do that. And looking forward to seeing some presentations next time.
Me too.
Can you, Christian, do you want to send me the recording as soon as you have it, and I'll post it, and then I'll tell the participants that it's there. Yeah, I will do that. Actually, I will end the recording now. So, and I